I think most of you know, my name is Dan Boggs. I'm in the product management team at Nexenta. And for the next presentation, we have Braden Delmore that's going to be talking about InfiniBand with Nexenta and his experiences with it. So Braden, it's all yours.
Great, thanks Dan. So I am system administrator for 1A Auto Parts, an online retailer. We've got distribution centers around the country. We ship auto parts. It's nice. I just run the data center. So. It'll take me a moment to get warmed up. I want to give you some background on why we use Nexenta in the first place, why we need open storage. We have online videos of how to repair your car, so we store the raw HD video. That requires lots and lots of storage. We've got 300 virtual machines. That requires lots of storage and lots of I/O for our crazy internal applications. I've got my end users. They're my documents are folder redirected to CIFS shares. I'm running MSSQL that's taking advantage of iSCSI, specifically iSCSI RDMA, the SRP protocol with InfiniBand. So I'll be focusing mostly on that. But I need to store lots and lots of data, and I need a lot of bandwidth. So I'll start with what are the advantages of InfiniBand. In a small business environment, frankly, there's not a whole lot of advantages with InfiniBand versus 10 gigabit Ethernet. I needed to solve I can't trunk gigabit connections together anymore. Once I've got 4, I can't add more interfaces. So I just needed to solve that problem. My 300 VMs, my users, my Windows were all using the bandwidth. I was just saturating. It was not good. So I could go to 10 gigabit Ethernet. For me, the cost in my particular environment was prohibitive. The 10 gigabit Ethernet switches at the time just too expensive. This was about 2 years ago. Versus the cost to implement InfiniBand for me, it's about 25% of what it would cost for 10 gigabit Ethernet. So financially, I didn't need the upfront capital. It cost me more man hours because I had to learn the technology a bit. But upfront capital was the issue for me. But there were a lot of other incentives for me to use InfiniBand. For instance, I've tried to work with TCP offload engines with gigabit or 10 gigabit in the past. And if any of you have done that before, you might have noticed that sometimes the drivers can be a little finicky or flat out not work. I understand that things are better these days, but the adapters themselves are, of course, still expensive. If you're using something like RDMA with InfiniBand, you get those offload benefits right out of the box, assuming out of the box you get it working. Obviously, the big draw for InfiniBand, a lot of people, the reason why you're paying attention, I imagine, is because of those big bandwidth numbers, 20 gigabits, 40 gigabits, or even 120. That was valuable to me. It wasn't the key feature. Just breaking 4 gigabit was good enough. And in fact, frankly, with IP over InfiniBand, that's usually all I can reasonably expect. Most of the time, there's enough overhead in my particular deployment that it's not far better, but it is better. Let's see, what other good things about InfiniBand? The low latency. Yes, the low latency, of course, was a big draw. And when you talk about InfiniBand, a lot of numbers get bandied about, like 1.2 microseconds, point-to-point latency. And to me, that never meant anything. I don't necessarily need the low latency, but I also understand the 1.2 microseconds of one. So we'll be discussing specifically going up and down the TCP/IP stack and up and down the iSCSI stack, to get a block of data. How long does that take? That's a real world. I'm actually doing something. It's not 1.2 microseconds ping. So I'll give you that. Move on to why not InfiniBand. First of all, it's not supported. So that's a big disclaimer right there. You're not going to find support for it. Don't do it. Don't try this at home office. That said, if that's not an issue for you, other reasons why not. Not supported not only with Nexenta, but not supported very well by the industry at all. I mean, if you really need it, then you've got the resources to put behind it to code applications for it and whatnot. In addition to that, this is not plug-and-play technology. You can't just drop it in like 10 gigabit Ethernet and have it work. You need to, have some experience behind it. You need to, do a lot of reading and research and make sure your drivers are lined up. So it's not quick and easy. That said, it's not as hard as you've heard. I mean, a lot of people have tried InfiniBand. I've seen tons and tons of InfiniBanders adapters up in eBay because people tried it and gave up. It's just annoying to deal with for them. It's not that difficult. It just requires a little bit of planning. Check your hardware compatibility lists. In the context of Nexenta, what worked with OpenSolaris, for the most part, still works right now. The bits haven't changed. So if you were working with it then, you can still work with it, without vendor support. And what about other than InfiniBand? In terms of 10 gigabit Ethernet, or there's fiber channel as well. I won't be getting into that. That's got its job. I use InfiniBand where fiber channel would probably normally go. But things coming down the pike are, RDMA for 10 gigabit Ethernet. So you can get a lot of InfiniBand-like capabilities in these 10 gigabit packages. So if you need some of the features or want some of the features, some of them are available now, some of them will be available. I don't understand this data center bridging switch technology yet, but I understand that also has the goal of providing some InfiniBand-like functionality. Oh, I should add before I get too much further that this should be a very conversational format. So if anyone wants to interrupt me, if I'm going off on a weird track, please just jump right in. I want you guys to participate as much as you possibly can to fill up the time I've got available.
What else have you used InfiniBand on besides OpenStorageSummit?
Oh, well, that's a good one. I'm using InfiniBand with my Zen VM infrastructure to actually serve as the interconnect between the Zen nodes. So, for instance, if I want to do a live migration of a VM from one host to another, that'll be going over IP over InfiniBand. And that works pretty well. I usually see about 5 gigabit doing that. Since I'm using it specifically with Zen Server, I had to do some weird things to make that work because Zen Server likes to get involved with the layer 2 of InfiniBand. Or not the layer 2 of Ethernet rather. And so I had to put in a little proxy ARP layer so it could respond correctly, because layer 2 for InfiniBand is very different from Ethernet. That's one example. Of course, I've got Windows talking to Nexenta for my iSCSI. So all of my back-end traffic for the data center is over the InfiniBand. The end users are using the gigabit to reach the Nexenta box. This will actually be very short.
What else besides, so you mentioned 5 gig on your InfiniBand, what other speeds have you seen?
Well, as far as the Windows goes, this is for a SQL Server format. It can actually pull a full 20 gigabit, 20 gigabit InfiniBand. InfiniBand uses 810 bit encoding, so you lose 20% right off the bat. So about 16 gigabit. I can actually pull 16 gigabit of real data from my application right out of the ARP cache, right away. And that's pretty neat. I've got some numbers for that for you. I think that's about it for other than InfiniBand. I'll come back to that later.
Which card work the memory card?
Sure. You said that you were working with it and it was working okay. Certain drivers for Nexenta only work with certain cards. For instance, I'm using the ConnectX boards, and they're working okay for me. They don't have any onboard memory. Specifically, I'm using the Supermicro branded ones. but I understand that some of the InfiniHost 3 adapters with onboard RAM also work. Like I said, it's mostly a function of what was on the hardware compatibility list for OpenSolaris. So those work out pretty well. I'm using 5.6 Feature Pack 2. Or is it Feature Pack 1, Service Pack, something or other? I get those mixed up. It's 5.6 with a Service Pack or a Feature Pack. I also can't stand it when vendors say R2 on stuff, you know. It doesn't make any sense to me. Give it a new number.
Do you need any additional driver or
Well, for my Linux and Windows systems, I'm either using Mellanox's branded OFED stack, or I'm using, just for the Windows box, just the regular OFED. On the Nexentis box, I don't need to use any additional drivers. There's the Tabor driver, or Tabor, I can't remember, for the InfiniHost adapters, and I'm using, for the ConnectX, the Herman drivers, and those work just fine for me. That said, just fine comes with some caveats. I can't use, in my environment, InfiniBand in connected mode right now, which would give me some performance benefits. I've only got it working in unreliable datagram mode. And the biggest distinction between the two is in connected mode, reliable connected mode, when your system does an RDMA operation or any InfiniBand operation, it's going to get a response saying, yep, this is good, this is good. It's going to get an ACK, if you will. And in unreliable datagram mode, you don't get that activity. But that's fine by me. Oh no, I did this. I had a bit of a challenge because I'm using this in production. I don't have this in a lab anymore. So I actually had to wait until the wee hours of the morning every few nights for the system to become idle enough for me to get an actual representative batch mark without too much competition for I/O. And I didn't want to go demonstrate my particular disk I/O subsystem, so all of these tests that I've got are specific to just the ARC cache. So I made sure that everything was cached entirely in ARC. And they're all sequential. This particular result is at a Q depth of 8. And this is taken with IOmeter. So all the data I collected was with IOmeter. And this is from my production Windows SQL Server, making an iSCSI request to the Nexenta exported ZVol over RDMA, and then getting back, well, 1900 megabytes per second at a Q depth of 8 with 64K IOs. So that was fun. And then gigabit Ethernet, of course, doesn't do that. It's not a fair comparison. I don't have 10 gigabit in the lab to compare against, unfortunately. I would have loved to have done that for you. But as it was, my only test system was just the production one.
You think that's reduced connectivity? The 8 lines pretty well going up, and then the 16 doesn't connect that much, and 64 obviously.
Well, quite frankly, I didn't overthink it too much. I couldn't tell you why it was exactly like that. I can give you my suspicions. I suppose another distinction of connected mode versus datagram mode is in connected mode you can actually send 64K size messages, and in datagram mode your message size I believe is going to be 4K. So that's your MTU equivalent. So and with my Ethernet, I haven't tuned that for storage. I just happen to have the interfaces handy, so I don't have any jumbo frames going. So this is very poorly optimized InfiniBand versus very poorly optimized Ethernet. So, but you can get numbers like that pretty easily. Again, that's just out of the I haven't, as far as SRP identifying all the drives, the way SRP works is it's still going to use the IP layer to identify what LUNs are available and whatnot. Not necessarily the LUNs. It's going to find the iSCSI target group using the IP layer. So I have my drives divided up to various groups. That said, once you've got them there, you can not use the LUN. You can just leave it offline. Something I should have out of the lab next week, which is not helpful to you now, is whether this all works with Microsoft's failover clustering. I have pretty high confidence level that it will, but haven't tested it yet. That just operates by toggling LUNs on and off. It doesn't have any visibility into the iSCSI layer, fortunately, so that should be pretty good. And up here, latency.
You don't restrict them which SQL servers see which one in your
Well, I do it all by identifying a remote initiator and choosing a target portal group. So I assign the LUNs to mappings that are specific to the machine. I do it that way. So that way I don't have one server seeing everything, because I've run into that scenario when I didn't group them up, and that was messy and unpleasant. So
yeah, last week when we came up with all the drives showed up.
yeah. So latency is pretty cool. Down here at the lower end, and this is at a Q depth of 1. 1 to 4 KIOs I'm getting, and this is again pulling the block at a Q depth of 1, right at the arc through the iSCSI stack. I'm getting my data in roughly 60 microseconds, which is pretty neat. So that's what I was referring to with that 1.2 microseconds not meaning much. This means something to me. This is data has appeared in my application to be worked on. In the context of SQL Server wants 64 KIOs. I'm getting those in less than 150 microseconds. So my SQL Server can start working on that block, and that makes me ecstatically happy. Staying within 64K size IOs, Ethernet latency, and I was trunking several of them together. Trunking, you can, of course, improve your bandwidth, but you're not going to do a thing about your latency. It's 1 or 4 connections. It's all going to be the same stuff. We're talking almost a millisecond there. Doesn't make a whole lot of difference for a little bit of I/O, but once you've got thousands of I/Os or hundreds of thousands of I/Os, then latency starts playing a big role.
What was the data set size? You said fit into the
These were all sequential reads from a data set of 48 gigabytes. I have a 96 gigabytes of RAM in my Nexenta store box. I got pretty good numbers out of random, but I didn't get enough of those tests to actually graph. Again, production, some batch scripts kicks off, and suddenly I've got IOs flying all over the place, and my tests look messy. So, but that works throughout the entire arc. I should probably mention that using Intel, an Intel Nexenta storage box with triple channel memory, so I've got a lot of memory bandwidth to spare there. Speaking of memory bandwidth, let's bring this up. Forgive me for jumping around. This is in the context of what RDMA can do for you. When you do a network operation, your request has to go through the TCP/IP stack. And when it does that, coming back, it's going to go through the TCP/IP stack and end up in a memory buffer where TCP/IP checksums are going to be performed or other operations of that ilk, unless you're using some sort of TCP offload. And then it's probably going to go to another buffer where some more operations are being performed before it reaches your application. So whenever you're going to do any operations with the network, you actually need roughly 3 times the memory bandwidth. I mean, you've got a lot more memory bandwidth than you do others. But when you start talking about 10 gigabit, if you're saturating 10 gigabit with TCP/IP, you're actually saturating 30 gigabit on just your memory bandwidth on the system bus. So by using RDMA, I can actually eliminate some of those copy operations in memory, and the amount of memory bandwidth saturation on the system bus is reduced by quite a bit. They call that zero copy operation. And in terms of the iSCSI stack, it's probably more like fewer copy operation instead of just zero. Oh, right, and that's what I was talking about there. I grabbed you some CPU efficiency. Moving things around in memory, dealing with the API stack, not having that TCP offload option does cause your CPU to do a little bit of extra work. So this is a measure of IOs per percent of CPU utilization. Obviously, the gigabit wasn't able to push as many IOs because it was bandwidth constrained, but each IO was more expensive, roughly twice as expensive for the system to do versus the InfiniBand RDMA operation. So I saw some benefit there for the CPUs. That's all the data points here are from the Windows side. So this is all from the perspective of my SQL Server.
Are you using iSCSI for all of your targets, or are you using an MS over RDMA with your set-top? With your
Well, I don't have any NFS over RDMA working right now. I wanted to get that out of the lab, didn't do it. Maybe in a couple months I have reason to believe it will work. Fortunately, I don't need it that badly. So all of my RDMA operations right now are just iSCSI for SQL Server. But one of the very nice things, of course, is that I've got the SQL Server coexisting, and I'm using the same link for all my hundreds of VMs. So the Nexenta box is actually providing a lot more bandwidth everywhere. So it was usually the Nexenta box that was saturated on the gigabit. I'm going to leave that. Anyhow, obviously I don't have a lot of clear direction here, so the more questions, the merrier.
What's the size of your and just how many servers you have? What have you actually got deployed?
Oh, well, there are 10 nodes, all communicating to each other over InfiniBand. There's a couple physical SQL servers. There's the Nexenta box, and the rest are Zen server VM hosts. Well, one of the things I liked about InfiniBand in doing my research before deciding to go for it, and this may be somewhat interesting, when you're working with Ethernet environments, as you scale the Ethernet environment out, you actually have more overhead for, say, spanning tree operations to go and do what they do, make sure you're not doing any crazy loops or anything like that. This actually introduces more latency into the Ethernet network, and this applies to pretty much TCP and 10 gigabit Ethernet, gigabit Ethernet, all in general. When you're scaling out InfiniBand, however, an overall map of the network is maintained by the subnet manager, and so by adding more switches for InfiniBand, you're not introducing just arbitrary latency all over the network. You, of course, have more latency as you go bounce from switch to switch to switch if your node needs to talk to a resource that's further down the line. But that's more of a linear cost rather than sort of a exponential cost when you're talking about the switches. So it's a bit more scalable for me, at least as far as the math goes. But again, in my production deployment, it's just the 12 nodes on one switch.
And what kind of switching did you go with?
Well, I use super micro equipment, specifically their blade chassis.
Okay.
So
you're using their scale 4?
I actually believe it's the InfiniScale 3 in mine. I have the DDR InfiniBand instead of the QDR InfiniBand. So it was a good switch for me. It's right in the chassis. It does not have a built-in subnet manager, so I actually have to keep the subnet manager running in software on another node. And in fact, I actually run it on all of the Zen server nodes. So that way, if I need to take a Zen server down for maintenance, and the subnet manager happens to be running on it, it'll automatically fail over to another subnet manager, and my network operations will continue to make sense.
Can you tell me about subnet manager, what is it and why it's for?
All right. The subnet manager, if you want an Ethernet analog, you can kind of think about it as the entity that handles the ARP table. That's probably a poor analogy, but it's the one I've got. The subnet manager is going to assign the physical ports to other physical ports, assign GUIDs and whatnot, and basically tell nodes how to reach other nodes. So you have to have one. It will do a regular sweep of the network. For instance, with Ethernet, if you plug in a new device, it's going to say, "Hey, I'm here, gratuitous ARP." With the InfiniBand subnet manager, it's going to have to actually go and do a sweep and say, who's out there, what's going on. And so then it will add it to the table, assign GUIDs, things will get where they need to go. In some situations, you can actually run into issues if your sweep frequency isn't enough, where see things drop off, from what I've seen.
So it has to be a physical server?
Yeah, it has to have physical access to the host bus adapter. I suppose in some circumstance you might get it working with a PCI pass-through and virtualization, but that's just a theory.
They do make switches that have subnet manager.
Yes.
in the switch.
Yes.
It was literally just a matter of running.
Okay.
Yeah.
Right, just a matter of running an exe on like Windows box, Linux box, Windows. There's nothing else, you just started.
I had to tune my subnet manager a little bit for my environment to have it stable, but manufacturer defaults are a good thing when they're a good thing.
But it is not a big complicated piece of thing. Not like it sounds.
You certainly have to be aware that it exists, but
Nothing works if you don't have it.
that's right.
Card link, say that's ever connected to it, like.
But like I mentioned before, InfiniBand sounds hard, but I'm just a boots on the ground sysadmin, with some spare reading time, and I managed to do it. So, not a brilliant engineer here, just a guy. I can do it.
Have you tested the Mellanox 10 gig BTI at all?
Those are the adapters I bought. I have not, however, tested that functionality. Generally, when I'm working with InfiniBand, I try to get it working in a Linux environment first. So that is on my roadmap. And in fact, that was my fallback plan. In case I could not get InfiniBand to work at all, I already bought the adapters that were supposed to be able to do 10 gig E. So I figured, worst case is I'm out the cost of the InfiniBand switch, which was very low cost investment for me.
Yeah, I'm curious to find out how that compares to native 10 gig and whether or not there's any overhead or tax for using the virtual protocol.
Well, on the physical layer, 10 gigabit and InfiniBand are extremely similar. So I imagine you wouldn't see really any overhead there at all. I think it would just be like any other manufacturer's 10 gigabit adapter. And of course, the ConnectX VPI adapters do support a lot of the neat InfiniBand-like functionality, like RDMA over 10 gigabit, ROCE or ROCE is the term that they're banding about now instead of iWarp, which was what they were discussing before. But that's what I was referring to when I mentioned that RDMA and InfiniBand-like functionality is supposed to be coming to 10 gigabit or already here. I've been keeping up on the market because I have InfiniBand and I'm happy with it.
now full duplex?
Oh, it's certainly full duplex. In fact, you know,
People not trying to 10 gig yet, or?
I haven't read any of that material, but in fact, this, I should mention, was unidirectional traffic. However, if I were doing writes, I have a DDR drive for my Zill, which I like very much. And if I want to write to that, which is a device that can receive data pretty quickly, bidirectionally, I can actually achieve, I think I achieved 2,600 megabytes per second doing bidirectional traffic. But more specifically to your question about collisions and whatnot, InfiniBand isn't quite like Ethernet. It has a built-in flow control mechanism, so it's guaranteed to, for instance, deliver your packets in order. It doesn't have any methodologies for dropping packets. It's gonna, if the remote system's buffers are full, it's gonna wait, do the flow control instead of sending data that may then get dropped. So that's one of the other wonderful things about InfiniBand. But you know, we're all used to working with TCP. We're all okay with dropped packets. Not so much on our storage backends, but you know, if we're using iSCSI, we're used to dealing with it. And if we thought it was unacceptable, we'd probably have to move over to fiber channel. Unless we're being brave and trying to go InfiniBand. Well, big bugs would include, I don't have connected mode working, like I mentioned before. That was probably the least pleasant. As far as the Windows side goes, the first thing I tried to do was use Mellanox's branded OFED stack to get my SRP working, and that doesn't seem to work with Nexenta. The OFED stack works fine. The OpenFabric's a line stack, so I used that. I was pretty happy. Is Excel on this thing? Just out of curiosity, I actually have a really nice pivot chart. Put it up. 2010. Just get that ready in case you So I actually have a few more measurements here available. I don't know what Excel. Okay, well, I've broken Excel. I'm an open office guy. Any other questions for me?
From what I've read we do need masquerading in the subnet manager
Masquerading, like IP masquerading, or?
I just read here from Google and I found a website that tells that we do it basically masquerade trying to other subnet manager, because if you want to ping from one host to another host,
Mm-hmm.
you will need first to masquerade one host and to talk to each other.
Well, there is some address translation. So the subnet manager's job is to assign addressable IDs. I haven't come across that, as far as I know, in my work with it.
Okay. You can talk about that now.
Yeah, you'll have to show me the article. That would be good.
That was actually related to running multiple subnets.
Multiple subnets.
So you have to do some translation to get from one subnet to another.
Oh,
public.
so InfiniBand routing then?
Yes.
Okay. Are we referring to routing InfiniBand to other InfiniBand subnets, or
No, routing.
to an Ethernet network or something like that?
Leaving
alternative fabrics, like InfiniBand or Fiber Channel. You're still using your Fiber Channel for storage. But then you also still have gigabit interfaces that you're using for that sort of thing. So if I need to leave the InfiniBand box, use the InfiniBand or the gigabit interfaces. When you're using IP over IB, you have a very intact layer 3. So anything you want to do to route a packet, you can certainly do. And in fact, that's how I get my my Zen servers to talk to each other. And that's why I've got a little bit of overhead and I can't achieve really impressive speeds. Is I'm actually compensating in Zen server by routing the InfiniBand IP over IB explicitly through the InfiniBand management interfaces, through the bridges. So as far as that goes, when you need to leave, just use layer 3 routing and it's fine. Got perfectly intact IPs. Packets. That's what the word is. Packets. Anything else? Don't feel trapped here, by the way. It's a short one.
Have you used any of the QLogic InfiniBand cards?
I have not. That's a short answer.
Have you heard anything encouraging from Nexenta about future InfiniBand support?
Well, Nexenta doesn't officially support it. From what I've heard, they would like to, but that's as close as I've gotten to a concrete answer. Something they would like to support in the future. But
We're working on plans for InfiniBand support, but nothing really to announce here.
Any time frame?
Still working on plans.
It's not supporting InfiniBand, some of their products, right?
well, for instance, Oracle's Exadata product does use 40 gigabit InfiniBand to connect the data storage and compute nodes. So, and that's using, I'm sure the Exadata product's using ZFS right now.
Good question. I think it is.
I believe so. I think they released these fancy new revisions to their Exadata product when they bought Sun, and I'm assuming that they're using all the wonderful good Sun IP that they got. But that is using InfiniBand interconnects. And of course, there's lots of other companies using InfiniBand, but mostly in the high performance computing arenas. I think they've got over half the top 500 supercomputers right now, InfiniBand users. It's popular anywhere very low latency is imperative. Thanks for having me. Oh, you're too kind. Thank you all very much for listening to that.